Hello. Seems like it's going now. Sorry, we got started a little bit late. Just had some technical difficulties to iron out. Let me just make sure we can see everything okay. It looks okay from my end. CJ, is everything looking good? Hello. I'm not sure how to pronounce your name, but hello. Can you hear me? Is everything clear? Okay, great. Excellent. All right, let's get started because we are going to make a game in 2 hours in PICO-8. So yeah, just to go over what's covered in the meetup, but we're going to use a lot of different PICO-8 tools. We're going to use lots of different functions in PICO-8 and try to hit like all kinds of standard problems you're going to run into during the game jam if you're going to use PICO-8 to make a game. And hopefully, if you've never used PICO-8, this is going to inspire you, or make you understand that you can do it too, because it's incredible and very fun to use. Audio is soft. I will turn it up. Is that better? I just didn't want to be too loud. Okay, great. All right, let's get started because there is a lot to do and only slightly less than 2 hours to do it, or about that. This is PICO-8. I'm going to use the primary editor in PICO-8 to. Oh no, resizing the window messed it up. That's not great. Let me fix it really quick. Sorry. The community in PICO-8 oftentimes they'll use external editors to make the development process a little bit easier, but I'm going to use the standard built-in editor just to show you that you can do anything with it. I'm going to be looking at the chat, so if you have any questions or suggestions, please don't hesitate. And I'm going to try to do my best to explain, but I'm going to move quickly probably. So let's get going. We're gonna create a pretty basic adventure game today. 2D adventure game where you can move between areas, pick up items, interact with enemies, and hopefully do something like doors and keys, maybe some really slight puzzle mechanisms. And we'll try to make it look good as much as we can in the time allowed. So I always like to start my PICO-8 projects by defining the 3 basic PICO-8 functions. These functions are called automatically by the PICO-8 engine. The init function is called once when the. Oh, where's my keyboard? Great. It's not going to let me type that underbar again. Okay. So these 3 functions are called automatically by PICO-8. Init is called when it starts running. You can push Control R and start the game. It's not doing anything. So update is called every frame. As a default, 30 frames per second. You can do 60 frames per second version, but I won't be doing that today. And then draw is called also once per frame to update the graphics buffer. So the first thing we're going to do is we're going to make a really simple map and move around it. Just because in the essence of time, we're going to use this is the sprite editor, by the way. I'm not going to go through all the tools, but I'm just going to make a gray block. It's just a square right now, and we're going to start with that. This is the map editor, and you can use it to assign the sprite we just created. I'm going to assign it to the map. I'm going to draw. I always do that the first time. I'm going to draw an 8x8 room for the first area. There's our room, 8x8. And we're going to display it on the screen. So the first thing we've got to do is we've got to do a little bit of boilerplate. The game will have a couple different modes, and the reason why is because we have to separate intro, game over, win states, and things like that. So I always like to do a separate game update for like the primary game mode, I guess, and a draw function too. And the other thing I want to do is, since this is the game mode, I'm going to go ahead and put the map stuff in this area, in this section as well, I think. And what I'm going to do is I'm going to write a function to draw the area, which it should draw like the current, whatever area we're in at the time. And I'm going to start with the map function, which will take this map and display it to the screen. We're going to do it from the first tile, from the first pixel, and we're going to do 8 tiles wide, 8 tiles tall, and we're going to go ahead and put this into the game draw function. Like that, and we're going to come back here and call our game draw. Let's also clear the screen first. We run it, and there's our map. Not much to look at, but it's a start. So the next thing is I want to display the map in the center of the screen because I don't want to do a full screen thing. I actually, in the design that I have today, I kind of want to do a sort of more like dungeony feel. So I'm going to move that to the center of the screen, but I'm going to use a different PICO-8 function to do it. You could specify X and Y coordinates right here, but instead I'm going to use a camera function. What the camera function does is it moves the graphics buffer, I guess, and I'll explain how that works in a second. I'm going to make a little object that's going to hold the current camera location, and I'm actually going to put it at -32, -32. And the reason why is because the PICO-8 camera works a little bit backwards, is what you might think. So you'd think that maybe if you want to draw in the middle of the screen, you'd move it down. The screen is 128 by 128, by the way. You'd think that if you want to draw on the screen, you'd move it down 32 and 32. But instead, what you need to do is you need to move it up into the left 32. So when you draw 0, 0 appears in the middle of the screen, if that makes sense. So you're not moving the starting point. You're kind of moving the meaning of 0 in that sense. So by moving the camera back this much and telling it to use these, it'll put our map in the center of the screen. Next, let's get a little bit of character going. I'm going to make a new tab because the player is pretty complicated. So let's make a little player object. If you've never written Lua before, also please feel free to shout at me if there's something that doesn't make sense. And we're going to do, player update, just like everything else, and the player draw. Japanese keyboard. Player draw is going to be pretty simple because we'll do a sprite later if we have time. That's how game jams are. We need to focus on getting the core functionality out, and then we can make it look pretty. But we're going to put a circle on the screen. We're going to put it at the X position and Y position. Give it a radius of 3, and we'll make it a blue color. This 12 is right here, this blue color. So that will draw our player on the screen at this X and Y. We come back here, game draw. After we draw the area, we're going to draw the player. Okay, let's move. So input, it's going to happen in the player update function. The way input works, screen that shows the map. I'm pushing Control R to run the game. And the map editor, if that's what you're talking about, is up here on the top. But whenever you see the game running, I'm pushing Control R to execute it. Okay. So we'll do input. The way input works is you have this function called button, and that reads buttons from the keyboard. There's a couple other functions, but this is the one I'm going to be using mostly today. And PICO-8 actually has these nice little macros. So if you hold Shift and push U, you can get this thing that looks kind of like an up character. And if you do an if statement like this, it actually means the same thing as if the up button is pushed. So I find that kind of nice to look at and very PICO-8, very fitting for PICO-8. So we'll start out this. We have up and down, And we also have left and right. Right. And I'm going to do something that might seem a little bit arbitrary right now, but what I'm going to do is I'm actually going to store the player's movement vector in kind of a different way. I don't want to write the player's X and Y directly. And the reason why is because we have to do a lot of things later, like test for collision. So instead of updating it directly, what I'm going to do is I'm going to update these Vx and Vy variables that I just created. So when we go up, we're going to say, Vy is -2. If we go down, we'll say Vy is 2. I actually should do this instead. I should make a speed thing here. Yeah. We can do it by player speed then. So instead of this, I'll say player speed. And we have to do the same thing for X. Going left is negative, going right is positive. And at the end of the update function, we're just going to update the position. Let's come over here, make sure we calling player update, because we made it, but we aren't calling it. And game update. One of the cool things about PICO-8 also is if you plug in a USB controller or Bluetooth controller, it works pretty much automatically. So I don't have one handy, unfortunately. It's much nicer to play these kinds of games with one, but we've got movement. Unfortunately, you can still walk through the walls, so that would be a good thing to tackle next, just so we can get our kind of world feel down. So there's a bunch of different ways to do collision. What I'm going to do for map-based collision, this is to say we're going to draw tiles and do collision based on those tiles, is I'm going to actually read from the map directly. So what I'm going to do is I'm going to first get the tile X. That is the tile that we would move to based on our X input. So we're going to get the position the character wants to go to and check that position and see if they can go there or not. The function you use is called mget. That reads from the map. And you give an X and a Y. And one of the gotchas is that these map coordinates are, you can see it says this is X is 0, this is X is 1, but each of these tiles is 8 pixels wide. So when I'm doing the player's coordinates are kind of in like sprite or pixel space, and the map coordinates are in map space. So if you think about it like that, these X coordinates I have to translate. So we have the player's position plus the direction they want to move, and we're going to divide it by 8 because it's in pixels and we want to convert to map tiles. One thing to keep in mind when you're doing this is this is a floating point divide. If this doesn't make sense, then ignore it, but this is a floating point division. If you actually use the other slash like this, it becomes an integer division, and that makes it so you don't have to deal with like rounding. So we're just going to do get the tile that they want to go to on the X. We're going to do the same thing for the Y. Oops. Divided by 8, and then player.x plus, Y plus Vy divided by 8. And then we're going to check the tiles of those locations. Oh, how does integer division work? The result is not an integer. Actually, PICO-8 is really kind, and it will handle it for you. I don't want to leave it to rounding. I want to do the rounding ahead of time, I guess. It probably doesn't make a difference in this case. But if you tell it to, if you give it an integer or a floating point location in pixels, it actually will do the right thing, which is nice because if you use them in animations, it can give you a smoother animation. Anyway, so I'm going to go ahead and get this is the tile. And what this does when I do mget is it returns the sprite number, right, which is 1. So when I have this number 1, it just tells me, what the sprite number is. But the sprites also have these flags associated with them. And I'm going to use this first flag here to denote that something is not a walkable tile. It's going to collide. So in order to get that flag, we use another function called fget. And we put in this tile number here. So we get the flags, and actually we're going to get the 0th flag for the first, or for every tile we're trying to go to. So if that flag is set for the tile we're trying to go to, then we're just actually going to set Vx to 0 to disallow movement on the x-axis. You don't want to use an else if here. You want to do a separate if else, and the reason why is because if you use an else if here, it'll block either on x or y, and we definitely need to make sure it blocks on both independently. That'll allow the player to like run into a wall and slide along it rather than just stop completely. Let's try it. Oh, somewhere I have a typo. Right here. What is it supposed to be? Oh, Vy. And the other thing, oh no, I think that's good. Oh yeah, it works. I can see that. You can see the position's a little bit off because the, where the circle is positioned in terms of x and y, it overlaps a little bit more on the bottom, but I'm not going to worry about that right now. So we've got basic collision, and just to play with it a little bit more, we can actually do some kind of like different shapes here, and they all work. You can't walk through it. But one room does not make a game, so let's make another area. And let's make a door. And let's go. That doesn't work. So next, we're going to make the areas, make it so it moves you between areas. The first thing we need to do is come back to this code where we're drawing the area, and we're only drawing 8 tiles. So 8 tiles is only the first room anyway. We'd never be able to see more than that. So let's make this a little bit bigger. I'm just going to go ahead and bring it up to 32. And now you can actually see the second room, but the camera doesn't move. There's lots of different ways to handle camera movement. In this game, I'm going to do kind of like an old school adventure game feel where when you get to the edge, the camera moves to the next area. So in order to do that, I need to move the camera when we get to the edge of the screen. And the way I'm going to do that is okay, so first thing I'm going to do is I'm going to make a function that gets whatever area we're in currently. So, because that's going to be controlled by the map, right? If we move over to the next area, we need to know that we've moved into a different area. But I'm getting ahead of myself, even still. I need to do one more thing before that, and that is I need to tell the game what areas are, because it doesn't know. So I have 2 areas that I've drawn out in this map, and I want the game to handle them separately. So I'm going to tell it the first one is at x of 0. This is I'm getting from here, x0, y0. And the other one is x8, y0. That is that. So x8, y0. So in the game I have, this is just setting up a little table so that I can keep track of, entities or enemies or whatever on a per area basis. So I told the game that I have 2 areas, and now I need to find, calculate what area we are in at a given time. I'm not going to do variable size areas this time. I'm just going to set them all to 8 tiles wide, 8 tiles high. So I'm just going to kind of hard code it in this function right now. For a given area in pixel space, let's do, let's actually just go ahead and name these like this so that I can do this. X equals the one you pass in, integer divide by 8. And we're going to do y at the same time. You can see I did this little thing where you can specify both in one line. So that gives us the positioning in tile space, map space, rather than pixel space. And then we're going to check and see what area that lands in. The way we're going to do that is we're going to loop through the areas that I have defined in that little table above. This is a for loop, and it's using the pairs function. What the pairs function does is it loops over a Lua table. And for each object in the Lua table, it gives you a key. So like, 1, 2, or whatever the key is, if you're using strings for keys. or and then the v will be the value, so it'll be the actual area. So, for example, it'll loop through and do 1, and then the v will be this object right here. And what I'm going to do is I'm just going to say if the x that we passed in is greater than or equal to the area's x, and it's less than the area's x plus 8, and y is greater than or equal to the area's y, and y is less than the area's y plus 8, in that case, we're going to return that area, and that's it. If it doesn't find it, it will return nil, and something will blow up, and that's what we want, because we want it to fail if it's not right. So now we have a function. We have these areas mapped out in the game. We've got a function based on x and y to tell what area we're in at a given time. So let's do that now. We're going to come down here to make a new function that I should have created a second ago called area update. And what this is going to do is it's going to, well, for starters, let's just keep it simple. We're going to set the camera x to be equal to our base camera x with -32 plus the x of our current area, which I just realized we don't have that set anywhere, so let's do that. This should work, right? This should work, right? No, I need to, where do I calculate the area? I guess I can do that here. Yes, that's not crazy, right? That makes sense, right? Okay, I think that'll work. We're going to do the camera's offset is the base -32, but then we're going to add, the offset of whatever area we're currently looking at, multiplied by 8, because we have to go from map space back to pixel space. This won't be an animation. It's going to be kind of like a jerky movement, but we can make it look nicer later. And we need to come back over here and make sure we do area update. Look at that. So it's kind of hard to see because the whole map is displayed, but it's keeping the area you're in at the center of the screen at all times. In order to make it look a little bit better, we're going to make it so we only draw the area that we're looking at currently. And the way we can do that is we can use the clip function. And we're going to tell it to clip from 32 pixels. That's, fourth the way into the screen. And we're going to clip a box the size of 64 pixels, which is 8 tiles wide, 8 tiles high. And then we're going to draw the map. And then we're going to turn the clipping back off, just so, for UI or something we do later. And the end result is you get the current area in the middle of the screen. And when you move to the next area, intuitively, the player moves back to the entrance of the area you entered from, and it shows only the area you're currently in. So with only a couple lines of code, a bit of camera magic, and some map functions, we've already got a game that, it's limited only by the number of areas you draw here and whatever you define in this section here. Okay, so with that done, I think the next thing we should do is enemies, because I think that it can't be a game unless we've got like enemies and health, right? So let's do some enemies, I think. I said enemies, but we're actually going to do entities. We're going to call them entities. I imagine a lot of people have used Unity or Unreal before, and you can do basically the same thing in PICO-8. And I like to organize objects that way because it feels more flexible. I like to build kind of like an entity component system on top of PICO-8 to allow me to add and remove enemies dynamically and things like that. It'll help us later. So first, let's design a little enemy because we need something. And I'm going to make a little bat. I think I made it too tall. There's a bat. And actually, we're going to make him fly. So it's going to look kind of like that. Okay, I have to stop playing with the bat. So entities. What we need to do is we kind of need to define what all the potential entities are in the game. And I like to do something, I always do this differently, but I'm going to call it entity def. And this is going to be a table. And all this is going to do is this is going to tell our game how to translate tiles into entities and how to generate entities from those tiles. So our sprite is 16. So I'm going to say S is 16. I'm not going to set any of the other bits, but there's a couple things I like to set out of the gate, and I want to do an update function and a draw function. You could do separate ones. You don't have to put it in the table like this. There's a lot of reasons why this is why that's better and this one's better. I'm just going to do it this way because I like it. So we have an update function and a draw function, and we've defined this entity. But the problem is that we can add this bat to our map, and we run the game, but it's still just a map tile. It's not an entity, and it's going to be, if we do map-based collision, that's fine, but it's kind of going to be limiting to only move it 8 pixels at a time. So we don't want to use map coordinates to move the bat. What we want to do is we want to read the bat from the map at load time, and then we want to erase it and handle it separately. So we're going to make a function called entity init. And what this is going to do is this is going to read all of our entities on our map and add it to the areas that we've defined. So we're going to loop over the map. Let's do this. And for each spot of the map, we're going to get the area that's associated with that spot. So we are in pixel space, or we are in map space. So let's move to pixel space by multiplying it. And then we're going to get the tile that's at that map location, which is mget again. These are map coordinates, so I don't need to multiply them. And I'm going to come in here, and this entity, remember we used the first flag for collision. So the second flag, or flag 1, is going to be used for entities. So I'm going to turn that on. And we're going to test it. So we're going to say if the first flag 1 is set on the tile that we are looking at. Then we are going to add that. We're going to create a new entity from that tile, and we're going to add it to the area. A couple things. It's possible that we don't have an area defined at this location, so we also want to check that. So we can also say if A. That will just make sure it's not a nil table. So we have an area defined. And another thing I want to do is I want to check first to see if A has like an entities table, because we didn't create one, right? This table doesn't have entities on it. But I don't want to make a bunch of empty tables for no reason. So I'm going to say if the a.entities table doesn't exist, then I'm going to create it. Then let's make a little entity. So what I'm going to do is I'm going to make a new table, and I'm going to get the x position, translate from map space to pixel space. That gives us a little entity. All we have is the x and the y. Now I'm going to do something that's kind of it's a Lua function, not a PICO-8 function. It's called a meta table. And I'm doing this so that any function or object we look for on E, if it doesn't find it, what it's going to do is it's going to come up here and look in this entity definition that we wrote before. And that makes it so we don't have to duplicate a bunch of fields on every single instance of the enemy. They can share things like update functions. So we're going to set a meta table, and it would be better to define it somewhere, but it doesn't really matter. But the meta table we're going to use is this one. We're going to use entity def where s equals 16. Luckily, we have that actually. It's we don't have that. Never mind. I need to do this. Forgot about this. If we don't loop through the entities, we can't actually check that they exist in the entity def table. So we have to do that too. So actually, we need to do this inside here. We loop through all of the entity definitions. And if we have one, no, actually, no, we'll definitely have one. We have to do if tile. So the tile we're currently looking at is equal to the sprite, because that's the only way we have to match it. Does that make sense? Read the tile from the map, compare it to this value. If they are the same, then we're going to create this kind of entity. And that means that we can use v here, which is it's the instance, it's the entry in the entity definition table. If you don't understand this part, it's fine. So we're going to set the meta table. We're going to we created the entity. We're going to add the entity to the room. So add, or to the area. And then we're going to delete it from the map. Just set it to 0. Right. So entity init. We're going to come in here. And I actually should make a game init, but I'm going to do that in a little bit when necessary. I'm going to run it just to make sure it doesn't blow up. And it doesn't, so it can't be all bad. Oh, actually, we should see no bat. Yes, because now the bat is in the entity table, but it is now in the map because we overrode it. So now we have to show all those things that are in our map or in the entity table, but don't actually exist on the map yet. So what am I looking for? We need a new function. We need to do entity update, just like before, and entity draw. It's going to be a little bit different this time because we're not going to do it for a single entity. We're actually going to do for every entity in the current area. And we're just going to call that update function. I'm calling it with a colon because I want to pass the object to the function so that we can access it and make changes to it inside its own update function. We'll look at that a little bit more as soon as we need it. Then we're going to draw and do the same thing. Entity update, entity draw. So that should work, right? It did not work. Oh, it did not work because we have a draw function for our bat, but it's not doing anything. It didn't break, so it's probably fine, but we need to tell in the draw function for the bat that needs to display the bat. And remember I said we're using the colon. The first argument becomes, whatever I put in here, whatever I call it, but it's passing the object itself as the first argument. So that gives us access to this s variable. So we know what sprite to use. This function draws a sprite on the screen, by the way. But also when we created it, we also set x and y. So we know the x and y. So the entity's s, sprite value, the entity's x, the entity's y. Run the game, and there's our bat. I drew it after the player, so it looks on top. It goes on top of it right now. Okay. So next is probably collision, but we have to animate it because it just, I can't stand how it looks right now. So for animation, you need 4 things. You need a list of the frames you're going to use in the animation. In this case, it's 16 and 17. That's actually right here, right? These two. You need to know the current frame that you are on. You need to know the speed at which you want to animate. I'm going to call it a speed. I'm going to do it. That's in seconds. This is in time. One thing I want to point out is that everything I'm doing is going to be based on using delta time. I'm not going to do any frame-based animations. You shouldn't either. You should always use time. If you do frame-based animation, later you want to go to 60 frames per second or port it to Unity or something, and it completely falls apart because your animations will not work. So never rely on frame count. So 4 things: list of frames to animate, the current frame we're on, the speed at which we want to animate, and then a timer to keep track of like how far along we are in that animation step. Before I write the animation, we have to start doing time tracking, which we aren't doing right now. And the way we do that is we're going to make a global variable called t. I like to just use t because it's simple. And that's going to keep track of the time. And then we're going to use a global variable called dt for the delta time. And the way we do it is in the update function. We grab the current time on each frame. The delta time is the difference between the new time and the old time. So this new time we just got and whatever we had before. After we calculate the delta, we update the new time to be the time we just got. So every single frame, we're updating this delta time to some small value. You know, it's like, I don't remember what it is, 34 milliseconds or something, I think. It's a global variable, but I still like to pass it through for, I guess, sanity's sake. So I usually come in here and for each of my update functions, I pass through this delta time. And to make sure it doesn't break. It does not break. All right. Let's animate. So first we're going to do is we're going to, oh, actually this has 2 parameters. I'm calling with a colon. I always have to pass the object first. So that's E. First thing we're going to do is we're going to add the current delta time to the animation timer. If the animation timer has passed the threshold of the animation speed, that means that we're going to animate. And the way we do that is by first, we're going to add 1 to the frame. But we only have 2 frames here. And once this gets to 3, it's going to stop working. So we have to set it back to 1 in that case. And the way we're going to do that is by using a max function. And we're going to set it between 1 and, sorry, a little bit of black magic, but it's going to be the current frame modulo the total number of frames plus 1. And the reason why we're doing that is because there's 2 frames. What we're doing here is we're adding 1 to it. So we have 3 frames. We modulo the current frame by 3. So that means if it's 1, it stays 1. If it's 2, it stays 2. If it gets to 3, it goes back to 0. So in that case that it becomes 0, we max 0 with 1. Max takes the bigger one. So it always goes back to 1. It'll never end up being 0. If it's 0, we get an error. So in this case, it basically will only ever be 1 or 2. And if you add more frames here, it will just work. So this is good. We calculate the frame, and then we just set the sprite. From our frames, the current frame that we just calculated. And the last thing we have to do is set the A timer to be, we modulate with the speed. This percent modulo means, modulo the A timer with the speed so that it gets reset back to whatever it was before, keeping the remainder so that our timing is perfect, I guess. That should work as long as I'm calling entity update properly. which I have no, it might work. Nope. DT, nil value. So in entity update, I'm not passing DT. Run it again. Oh, this should be e.aspeed, not a.speed. Run it again. Look at that. Okay. Okay. So far, so good. Let's do collision next. Even though I want to make it move, let's do collision first, because collision is more complicated. We already have one kind of collision, and it's map-based collision, so it's tile-based, which is kind of, it's not great for characters because you fall on big pixel boundaries. And for characters, I know everyone's favorite is to talk about the AABB method where you match the squares, but I don't like that because I feel like it requires a lot more. It's more finicky. So instead of that, I'm going to use 2D circle-based collision. So in order to accommodate that, I'm going to set a collision radius on each of my objects. So I'm going to call it C size. And let's set it to 3, maybe. The first thing I want to do is come back up to my init function and set up a debug mode, because trying to debug without being able to see it is difficult. So I've set my collision radius here. Let's draw that. If we're in debug mode, and see this is the draw on the entity itself, then we're going to do a circle at the entity's location with the same size that I just set, and we're going to call it. We're going to make it white. So what you'll notice is the sphere is offset, and the reason why is because the sprite starts from the top left corner, and the circle starts from the center. We don't want to fix the circle because the circle is correct. What we want to do is we want to fix the sprite. So there's a lot of really good ways to do this, but I'm just going to subtract 4 in the draw function for the sprite. That's a lot better. So now if the idea is that if the character bumps into the circle, they should become damaged or something. Okay, now we have to make that work. In order to do that, we need a little bit of math. We really only need one function. It's the distance function. I always forget it, but I've been thinking about this a lot recently. So the distance function is the difference of the square, or the squares of the differences. So x2 minus x1 squared plus, or the sum of the squares of the differences. Yeah, that's what it is. It's just this thing you memorize and then put in here, and then it just works. Square root is slow also. I feel like somebody's going to say that to me, but it doesn't matter for this. Yeah, Pythagorean theorem, exactly. So that will tell us if it'll give us the distance between 2 points, which is not enough to say if we've collided or not, but it's most of the way. You need to come back over to the player and also give the player a collision size now. And I'm gonna do the same thing here and make sure that we have that drawing so we can see it. Player dots. I don't know how visible. Yeah, it's a little visible. So now we can see our collision spheres. There are lots of places you can handle collision, and I have done it every time I make something. I do it differently. So your mileage may vary. I'm going to go ahead and do it right in the player function here. And the reason why I'm going to do that is because I want to modify the player's movement if they bump into an enemy. So I'm going to check for player-based collision in this function. You could do it on the entity side too. It feels natural to me to do it here. So again, we're going to loop through all the entities in the area. we're going to check the distance. This is going to make things so it's going to assume that anything you bump into will give you damage, but we can work around that later. So all we have to do is check the distance between the entities X and Y and the players X and Y, and make sure that it is less than the player's collision size plus the entity's collision size. And in that case, we've collided. So to handle the actual collision here, I'm going to go ahead and stop the game entirely. Let's just make sure it works. And you can see it went back to a prompt because the game's not running. So that worked. For some value of worked. So next we need to think about what we're going to do when we collide. Right now, nobody has health or HP or anything. So let's give the player some HP. And let's come over here to our entity. And I'm not going to give the entity HP yet, but I am going to give the entity a new function. We'll call it collide. There's a bunch of different ways to do this too, but if I do a per entity collision, it gives you a lot of flexibility for making different interesting things happen when the player bumps into them. So this function will only be called when the player actually bumps into the enemy, or the entity, sorry. And in this case, we're going to say, we're not going to subtract from the player's health directly, because there's a lot of cases where we want to account for not hurting the player, and we don't want to put that in the entity's functionality. What I'm trying to say is we want to tell the player that they may have taken damage, but we need to leave that up to the player whether they did or not, because maybe the player has an item that makes them invulnerable, or there's a lot of cases where, you know, we need to handle separate logic to make sure the player doesn't take damage when they shouldn't. So I'm just going to add an entry to the player object here. I'm going to call it damage. And actually on update, I'm going to just go ahead and set it to 0 every time, assuming that the player by default takes no damage every frame unless we update it. And I'm just going to set their damage. I'll just add 1 to it. So they bump into the enemy, they're going to get a damage point. We come down here and call the collide function now. So the distance is low, they'll bump into the enemy, they'll get a damage point. We can come in here now and say, you could do it outside of the loop. I'm going to do it inside the loop, and I'll explain why in a second. But if the player's damage is greater than 0, I know this if is unnecessary, but I'll explain that too. So if the player has taken damage, then we're going to just subtract the damage from their HP. And another thing right now is come up here and say, if the player's HP is less than or equal to 0, then clear the screen and stop the game, just so that we have a way to know that the player has died. It should stop pretty quickly. So the player has 10 HP. You have to collide 10 times in order to lose all your HP. But the problem is that this function runs every frame. We have 30 frames a second. So, you know, within 1 second of bumping into the enemy, we've taken damage 30 times. So we need to make sure the player doesn't take damage for a little bit after they've taken damage. I'm going to make a little field here called invuln, which I'm going to use to keep track of the player's invulnerability. You know, in games when you bump into something, take damage, you get a few seconds of like grace period. And I'm going to set that to 2. And that 2 is in seconds. And when the player takes damage, we're going to set their invulnerability period to 2. Actually, I shouldn't have set it to 2 here because they'll start the game with it at 2, and they shouldn't do that. I'm going to set it to 2 down here. So they bump into something, they become, if they have taken damage from it, they'll become invulnerable for 2 seconds. And we'll also do, when they take damage, we'll check to see if they're invulnerable before we give them any additional damage. make this whole thing work. And one last thing, I want to be able to see the invulnerability period and the HP in debug until we have it all set up. So I'm going to set the cursor. I have to update the cursor because we moved the camera around. So if we want to draw on, if we want to print text to the screen, we've got to move the cursor. I'm going to print the player's HP. And I'm going to print the player's invulnerability period. Another thing I need to do is I need to make sure that the player's invulnerability period goes down. So I'm just take the maximum of 0 and the current invulnerability minus the delta time. Always time-based, right? So we subtract the delta time every frame from the invulnerability period, and it will go down over a couple seconds, hopefully. 10 HP, 0 invulnerability. If we bump the enemy, 9 HP in about 2 seconds. And if we walk over the enemy again, you can see the HP doesn't go down. Yes, that's 1 hour. We'll see how this goes, I guess. All right. What's next? We have collision, but it's super underwhelming because, thank you. We have collision, but it's super underwhelming because the player can just like walk through the enemies. It doesn't feel like there's any collision. So we're going to use a little bit more math to make it feel like there's collision. We're going to bounce the player back after they bumped into the enemy. Can I go over the entity init a second time? Are you talking about, yes, let's just go over it. So I arbitrarily chose these values, but for a value of x between 0 and 31 and y and 0 and 31, we're going to read the map. So what we're doing is we're looking at these tiles. Okay, we start at x0 and we actually go way out here, even though we haven't written anything over here yet. But first thing we do is we find the area associated with that square. So the first thing, if it reads this tile here, it says what area do I belong to? Well, 0, 0. So it calculates this. It says 0, 0, right? And then get area says area 0 is, oh, great. I'll just select and delete a bunch of stuff. Area 0 is, it's this one because it falls within the boundaries of x0, y0. It's within 8 tiles. So it says this is my area. Then what it does is it gets the tile. The reason why it gets the tile is because it knows the location here, and then it says, okay, well, what tile is at that location? It's this one, right? Which is this. So we read in that tile. So we know we have sprite 1. And then what we do is we say, if there's an area associated with this position, and the first flag is set on, this is entity. Yeah, sorry. And the first flag is set on the sprite, which it is for, not for the blocks, this is for this, right? Flag 1 is set. So if there's an area and flag 1 is set, then we create a new, in that area object, we create a blank table called entities if it doesn't exist. Then we loop over every entity definition that we have created. And if this sprite on the map, this sprite, it'll return 16, right? If it matches an entry in our entity definition, we create a new entity. And so for the bat, it looks through all these and it compares S with the tile number. And for that single tile, it's true. It says, okay, well, the tile number is 16, and we found this entry in the table right here. Tile equals v.s for each v, right? V is each entity. So it's true in this case. So what we do is we make a really tiny table that just sets x and y. And we do some Lua magic here called meta table. And what that does is it says, anytime you look for anything on this E, use whatever you find here. But if you don't find anything, then use whatever you find in V. And V is this guy with all of this stuff, right? So it goes and looks at the E object and it doesn't find frames or frame or A speed or any of those things. But when it doesn't find it, it comes back to this main entity def table and uses that copy. So it makes it so we don't have to have two copies of all of these functions, one per entity. So we set the meta table, and we add that object we just created here. We add it into the entities for that area, and we delete it from the map. And that's how we move data from the map into Lua memory so that we can, do more with it. Because I've seen, there's a lot of different ways to do it, and you can hard code enemy positions and whatnot in your Lua code. But for me personally, I want to use the map editor and set things up, and then write my code to, fall in line. So I decide now where the bats are, and I don't have to go and change any code. If I add another bat, even here, and run the game, it just works because it's dynamically creating those Lua objects from the map information. I feel like it's way more designer friendly. So hopefully that helps. Where was I? I was doing collision. Oh, bumping the player back. Yes, math, right. There's a lot of different ways to do bumping the player back, effects like that. But what the tricky part is that you get into a situation where, like, if you're above the enemy, you want to bump up. If you're below, you want to bump down. And you end up with like a web of if statements if you try to do it based on player position. So we use math, and now we have two problems. We're going to make a function called v toward, just because I don't know what to call it. And what v toward means vector toward. And this is going to return a vector for moving toward a given thing. I'll show you. It will make sense. It takes two positions, or y1 and x2, y2. And the way it works is, first, we calculate the difference between the two locations, vx, vy. And when you're doing vector math, and you want to make something move towards something else, you got to start at the position you want to move towards and subtract the position where you are. So we want to move x1, y1 towards x2, y2. So we're going to start with x2, and we're going to subtract x1, and then we're going to start with y2 and subtract y1. That gives us a vector, but the vector is not normalized, which means its length is bigger than 1 or different from 1. And if we use a vector that isn't normalized to calculate our movement, what happens is the enemy will move kind of at erratic speeds. So we have to normalize the vector. And the way we do that is by taking the square of the sums, the square root of the sum of the squares. That's what it is. The square root of the sum of the squares. So vx squared plus vy squared. That will give us the length of the vector. And normalizing works like this. You take the vector and you divide it by the length. And we return the vector. Returning tables dynamically like this is bad for performance, but I'm going to do it anyway. So we have this magic function that returns a vector heading towards a thing. What we're going to do is we're going to use that to bump the player back. So here when we've taken damage, right, in this function we know we've taken damage, this is where we're going to do it. So we're going to get our vector using the function we just made. And we want to move toward the player. We want to move the player toward themselves. Essentially, the player more in the direction that they are in, away from the enemy. So we're going to move toward the player X, away from the enemy's position. And then it's as simple as we have these VX things that already respect map collision. So all we have to do is modify those. So, right, here we get the input. We're modifying VX here. we're just going to modify that again. And if they bump into a wall, it's going to reset, which means that we don't have to do anything special. They won't move through walls or anything. We are going to add this x component from our vector to vx. It's going to be really small, so I'm just going to go ahead and add 8 or multiply it by 8, or else it won't be really visible. That should bounce us off the bat. Let's see. That did the opposite of what I suggested, even though I talked all through it. My logic, is it backwards again? No, it's backwards here. Because I said I wanted to move toward x1, and then I did it. I wrote it exactly backwards here. That. Oh, well, yeah, because that's that. You know, if you're invulnerable, I guess you can walk through the enemies. But what are you going to do? This function is magic. You can use it for lots of things. So I don't know how I should phrase that, but we're going to use that for something else now. So it's one thing to have, you know, walk around and bump into enemies and take damage and everything, but we need the enemies to move because they don't move right now. So we're going to make the bats move. And the way we're going to do that is pretty simply, we're going to have a variable on the bat called tx, and tx is going to be, I actually don't need to set it here. I'm going to do it right here. So if not e.tx. So if tx doesn't exist, then we're going to go ahead and create it. We're going to say e.tx equals the current x position. And what this tx and ty are they're the target x and target y. They're where the enemy wants to go. They're bats, so I don't have to worry about walls, so I'm not going to. For a more complicated enemy, you would need to check the map and make sure they don't bump into walls. But for this enemy, I'm just going to let them fly over the walls. So if we don't have tx, then we're going to create those base things. And now what we're going to do is we're going to check how far the enemy is away from where they want to go. So distance, again, the enemy's location from their target location. If it's greater than 2, which I just chose arbitrarily, but that should be pretty close. If we do equals, like directly equals, you might get some weird fuzzing when the enemy like can't find the exact spot it needs to be. So I like to set it a little bit higher. If it's greater than 2, that means they need to move toward where they're going to. So it's the same thing we just did. We do v toward. They're trying to move towards their target location from their current location. And it's just a matter of updating their position. Or this should be E. One thing is that vector, like I said for the player, I had to multiply it because it's really small. A length of 1 will mean they'll move at about like what, 1 pixel per frame, which is 30 pixels per second, which is pretty quickly. So I'm going to come up here and just give them a speed, which I'm going to set to like 0.5. And so now if they're too far away, they're going to move toward it. But right now, since by default we're setting it to the place they are, they're not going to do anything. So let's make the other condition, which is, I really should just calculate this once. I could just do else probably. Yeah, I can just do else. If they're, yeah, okay. So if they're, that means they're within 2 pixels or something of the place they want to be. So what we need to do is calculate a new place to go. And the way we're going to do that is we're going to say, we're going to use this AX, AY that I just made up. That's, you know, a target, or should I use those? Oh, area X, area Y. This is the target area they want to go to, I guess. Does that make sense? No. Does not make sense. We don't have to do that. We can just set the target area directly. Here we go. We're going to update TX. And we're going to set it to a random number between 0 and 64, because that's how big the rooms are. 8 by 8, 64. Or 8 pixels by 8 tiles. So we're going to set it, multiply between 0 and 64, random number, but we have to offset it by the area that they're in, right? Because everything's starting from the base position of its area plus 64, up to 64 pixels. So we got to get the current area. It would be better to get the area, programmer problem. It would be better to get the area this entity actually belongs to, but this function only runs in areas, only runs for entities when you're in their area. So you could work yourself, it could be a problem that comes from this code, but it's going to work right now. So you take the area as x, the base x value, I don't need parentheses there, and add it to this random number. That should do it, right? It should pick a new spot every time it gets close enough. Like that. That works. You could do a lot of stuff with easing functions to make it look nicer, so they kind of like speed up and slow down, but that definitely is the thing you do on Sunday before you ship the game, not the thing you do when you're trying to make the vertical slice. So we've got the enemy moving. I'm going to turn this debug off for a second. We've got the enemy moving. We've got collision. I guess it is a friendly bat. I mean, it does hurt the player, but you have a lot of health, so maybe it's fine. Right, we need to be able to defeat the enemy, unfortunately. If you're a fan of the bat, I have bad news, but the bat's gotta go. So the sword, I'm gonna make a sword just because I don't know, making a gun or something just doesn't feel right for this kind of game for me. Unfortunately, making a sword is really annoying because it has a base position and you kind of got to swing it out. And so you have to do collision based on the sword's individual position. So we have to do a lot of parts. I'm going to add a sword X. These don't really matter because we're going to update them. I mean, they might like flash. I might as well just set it like this. So we're going to have the sword's position. The other thing we need is we need to keep track of the sword's sprite, which I'll do that in a second. We also need to keep track of whether the sword sprite is flipped vertically and whether the sword sprite is flipped horizontally, because you can't rotate dynamically in PICO-8. I think that's probably enough. We probably also have to do something to tell whether the player is actively attacking or not. Let's make a sword. Let's do it over here to give us some space. Look, it's a sword. I'm going to copy that and paste it here and push R to rotate it. So now we've got a sword that we can use left and right as well as up and down. I did do some animation with it in a prototype, but I don't think it's very tricky to get the positioning right when you're doing like animation. We'll do that if we have time. So this is probably the most finicky part of all of this. I don't really have a good way to do this. We just have to calculate all these numbers. So the first thing we're going to do is set the sprite, which is 5. First, let's just put the sword on the screen. So it's player sword S is the sprite. Sword X. We're gonna use some new parameters for this sprite call this time. We're gonna tell it it's 1 tile wide and 1 tile high because we have to pass something there, and we're gonna say whether we want to flip it or not. Flip the sprite. The first one is horizontal, I think, And then the second one is vertical. Sorry, this line is super long. I probably could split it up so that it's more readable. I don't know if that makes things better. It just makes the code longer, but I know it's probably frustrating if it's off screen and you're trying to understand it. That is not the same. There we go. That looks fine. That's about what I whoa, that's not good. Okay, we didn't update the sword position, so let's do that. That's better. I mean, not much better, but it is better. Okay, so we have to do a lot of things to put the sword in the right position in the right time. So I'm not going to actually update it here. I'm going to make a little temporary variable. And at the end of the function, I'm going to update it. I probably could have just kept that. Oh, one more thing. I want to go ahead and do this now because it always bites me. We need to set the collision size and make sure that our everything lines up. Make sure the sprite lines up, because if it's out of alignment, then it looks like it's hitting, but it's not. I'm going to make the collision a little bit bigger because sword should be easy to use. Let's go ahead and get that debug circle on the screen. Admittedly, the way I'm doing a lot of this uses a lot of tokens. If you're not familiar with PICO-8, it has a concept of tokens. You have a limited number of tokens, so this 8192 down here, which means I'm kind of, if you write really complicated code, if you use like a lot of dots and stuff, they use additional tokens. And when you run out of tokens, you can't write any more code. So it's not the same as characters. Tokens are like a word or a symbol or something. So, but honestly, in a game jam, I don't think you're going to run out. I wouldn't worry about it. Just make the game work. You need to turn on debug. All right, so see now the circle is overlapping with the player, but it's not overlapping with the sword. And that is what I was afraid of. The reason why is because, well, it's because the, starts from the top right or top left of the sprite. And so we need to offset the sword sprite. And I think the way we need to do it is we actually have to add 4 here, because we're going to do a bunch of calculation. So we need to add 4 ahead of time, I think, and then subtract 4 at the end. And if that doesn't make sense right now, I forgive you, because it didn't make sense to me either, but I think that's what we got to do. And it looks right now. If we just add it in one place, then what happens is all like aligning the collision with the sprite at a later time gets more and more difficult, because now we have to do a lot of stuff to make the sword go into the right spot. For one, I'm going to put the player on top of the sword because I want them to be holding it. So now we've got to position it. And whoa, where'd it go? We need another field to know that we have to keep track of which way the player is facing so that we can put the sword in the right position. So you can see I set it to up. You can use these little symbols also as values, and it's pretty, I don't know, cute and easy to understand. So I set facing equals up in the init, but I actually have to set it every time we turn. I need to update it. So if we go up, I'm going to set it to up. If we go down, I set it to down. By the way, it's like Shift U, Shift D, Shift L, Shift R. We'll get you those. And that's not going to work because I didn't set this. If you don't tell it it's part of the object, it will create a global variable, and you won't know what's going wrong until things just stop working. So, okay, we know which way we're facing now. let's try and adjust the position of the sword. So we need to move it up. Let's turn off debug for a second so that I can see. So when we're facing up, we need to move the sword up, and down, obviously, we have to move it into the position of the right hand in each of these cases. So if the player is facing up, then move the sword up a little bit, like that. That's good, right? That looks like it's in the right hand. I wish PICO-8 had, or Lua, I guess, had some kind of switch statement, because it's tough to write out all the ifs. If they're facing down, what do we need to do? We need to move it over to the other side because they're right-handed, and we got to flip the sword. So something like this, and set player.sword, what is it? Flip H equals true. Yeah, oh no, flip V. Yeah, like that. Oh, I didn't, yeah. Also, you have to set it by default, or turn them off every frame before you calculate, otherwise they'll persist. You could do it in the if statement as well. I just feel like it makes more sense to set a default and only override it when necessary. They're a little bit different. I need to move it left a little bit on this one. So I think it needs to be -7. Yeah, now it's the same. Nope. I have to move it up 1. Now it's the same. Okay. Let's do left and right. No, that's not right at all. Sorry, this is probably the most grueling part of this kind of thing, but it's tricky when you're trying to align, sprites that are off-centered. I could probably I could probably do something like this and make my life easier, but I just have to add and subtract different numbers, I feel like. So let's go ahead and, oh, another thing we have to do is when they turn left, we have to update the sprite, because the sprite is 5 for up and down, but it's 6 for left and right, which means we also have to set this here by default. Probably don't need to flip that actually here. That's almost right. Or no, it's on the wrong side of the person. They needs to go over the top. So like this. Almost. Like that, right? Yeah. One more. I don't know what those should be, so. That's almost right. Just move it down, I guess. So don't need this at all. Yes, okay, there. Okay, we're holding the sword in the right position. Let's make sure that the collision is still correct. Okay. All right, one more finicky thing to do with the sword, and that is if you stab it, it needs to move forward. And that is annoying. So the way we're going to do that is we're going to use another local variable to keep track of the position, because if you're pointing this way, it needs to go negative, like less on the x. If you're pointing this way, it needs to go more on the x. So that's kind of annoying to calculate. So I'm going to use here ax and ay for attack x and attack y. I'm just going to set them depending on the direction. So if you're facing up, then your attack y is like -5 or something. If you're facing down, attack y is 5. And if you're facing, that is not attack Y. It's just A. If you're facing left, attack X is -5. And if you're facing right, attack X is 5. And here we go. We'll just add these values here. Or if we're attacking. And it's still not going to work because we haven't done the input. So let's let the player attack. If you do Shift X, you can do this little like X icon that's for pushing the keyboard button X, or like the A button on a controller. So if they push that button, we'll set attacking to true. Also, every single frame, I probably shouldn't do this here. Probably should do this up here. Every single frame we need to reset whether they're attacking or not and reread it because we don't want it to persist between frames. So we set it to false, we read it again whether they are attacking or not. Update the sprite and everything. I assume it'll work if I just push X. Turn each direction. Okay, that is good. Now, we have to let the bat know. And there are, again, a bunch of different ways to do this. What I'm going to do is I'm going to come in here on the entities, and I'm going to make a new function, actually, so that we can control on the entity side what happens when they get hit. So I'm going to call it hit. And if they get hit, I'm just going to say you lose some HP. I could probably make it so you could specify in the weapon or something, so you could pass it along, but it doesn't matter for this moment. We can add that later. So we added a new function, but it's not being used yet. We need to come in here and we have to do the collision. So we're already looping over the entities inside the player update. It doesn't take very much to just, when you're checking the distance between the player, you can actually just go ahead and check the distance. If we are attacking, then we'll also check the distance, not between the player X, but between the sword X and the sword Y, and not the player C size, but the sword collision size, right? Use the same distance function again, just check, instead of checking the player's bubble and the enemy bubble, check the sword bubble. And we're not calling collide, we're going to call hit. Another thing, we won't be able to tell if it's hit yet. I guess we have to do this if it's subtracting from its HP, but we need to come up here into the update function, because if my HP goes below 0, then we're going to just delete it from the entity list. So it's going to delete itself. And then it's going to just return because there's no reason to do anything else. Sorry, I'm really bad at comments, as you can tell, as I just keep writing code and not writing comments. We're going to give it an HP of 1 just because it's a bat. Maybe it'll work. Hey, that worked. Sphere collision. I don't know, I just feel like it's much easier. Sorry, yeah, I know the bat is really cute, but I tried to make it less cute when I was thinking about how to do this, but unfortunately. Okay, we're at 6:30. We have enemies. We have moving between areas. I really, really want to do keys and doors, and we have enough time, I think. But before I do that, we have to do a start and end screen and life, because you have to do that stuff before you do all the fun stuff. You have to. It's a rule. So I've used a bunch of tabs here. I'm just going to make another tab because I want to do intro and outro, I guess. I'm just going to make some little functions. Intro, update. I don't think it, oh, actually, intro update does need to do something. Intro draw. Intro draw is going to do, let's do another little helper function right now, just because I want to do a nice like title screen. Or first things first, let's just make this work, and then I'll worry about making it nice. We have this draw. It's just going to clear the screen and do nothing else. So let's just make that work, I guess, first. And we're going to do scene equals intro. What we're going to do is in our update function, there are a billion ways to do this also. This is not the best way, but it's pretty easy to understand. I didn't pass DT into intro update also. So now it will conditionally call intro update or game update, depending on whether the scene value is intro or game. We actually want to do the same thing down here for draw. I don't want the CLS in here either. Like that. That's all well and good. It should just boot up into a blank screen right now, because we're setting scene, but there's nowhere for it to go or anything. Let me just make sure I need to do a CLS here. Okay. So let's make a title screen. That's title screen, right? Let's print it in the center of the screen because it looks kind of nice. So we're going to make a helper function to do that. Call it cprint. We're going to pass in the text we want to print and the Y position because it's going to auto center it for us. And I don't know if I'll do this, but I'm going to go ahead and pass in a foreground color and background color. What we need to do is we need to get the length of the text, which you can actually do with this hashtag thing, this hash thing. If you use it on a table, it will tell you how many items are in a table. But if you use it on a string, it'll tell you how many characters are in the string. So we get the length of the string, and we say the X position is going to be equal to the center of the screen minus half of L times, right, that's not enough. I think the character is what, like 5 pixels wide or something, including spacing? That should be right. That should be right. We already have the Y, so really we just have to do cursor XY and print the text. And I'll just change this adventure to cprint adventure, and I'll set the Y to something near the middle of the screen. I'm not going to set the foreground or background. Hey, look at that. If you have any ideas for what I should call this, I'll take suggestions, because adventure is pretty, I feel like it's not very descriptive. I'm going to resist the urge to make this look pretty right now, and I'm going to go ahead and do the transitions first. So all we need to do is we need to check for a button press. Doesn't really matter, but we'll just use X. And if they press the button, we're going to go get right into the game scene. And it should automatically move us, so I'll just push X. Oh. Attempt to index global area, a nil value. So the problem is that halfway through the update function, it switched to a different scene. So a lot of things that we anticipated being set were not set just because things were kind of not called in the order expected. So we need to make sure that, because I think the problem is that like in intro update, I changed the scene to game, and then I tried to draw it before I actually ran game update a single time, and that's not great. So I need to make sure it runs the game update before, before it does the draw, which there are good and bad ways to do this. And you can see exactly what I'm going to do right here, which is not a good way. That's, oh, DT is not being passed in probably. Right here. Don't need DT on a draw. That's what I did wrong. Okay. Unnecessary violence, sorry. Okay, so I probably should do something like this. Right, just kind of probably would be good to tell them we can start the game. Well, that's too close. I can't tell if it's actually the center. I'm sure it is, though. I'm sure it's fine. Okay, so we have the intro. Let's do game over. I just copied and pasted all that. We're going to do game over update. And we're going to actually move from the game over screen back to the intro screen. And game over draw. And we're just going to say game over. Right? And now we just need another scene here. Well, not just. We need a bunch of other stuff too. But we do this. I'm at 40 minutes. It'll be fine. Now we have to actually be able to get a game over, which is, I didn't make the player's health visible yet, so that makes it kind of unfortunate. But here where we're calling stop before, when the player went back to 0 HP, but instead what we're going to do is we're actually just going to set the scene to game over. Well, that did not work. And the reason why is because we move the camera around a lot when we're making, when we're displaying the map. And so at the beginning of the game with the intro, the camera is actually defaulted to 0, but when we get to game over, it's not. So we just need to make sure that we reset the camera here, which you can just do like that. And just to be safe, we should do it in the intro as well. Let's try it again. That does not look centered. I think, yeah, that does not look centered. I wonder if it's because that X character is really long, or if my math is not correct, or if this order of operations is not what I'm expecting or something. Oh, 64? You could say 64 is the halfway point, but that doesn't really make a big difference. It's just 1 pixel. We're not going to worry about it too much. If somebody sees what the issue is and realizes, let me know. Okay, so we can get a game over. Oh, did I even test the going back to the intro? I think I just keep closing it. If you push X, yeah, that doesn't work. Scene equals intro update. Why didn't that work? Why didn't that work? X. Why is that not working? Else if scene equals game over, then game over update. Then it should update here and go back to scene equals intro. Oh, you know what? I sent it back to the intro. Well, no, actually, that shouldn't matter. But I feel like what's happening is I'm pushing X once, and it's going through the intro and then all the way through into it's the same frame. So it's going back to the intro and it's going back into the game, and the player still has 0 health. So it's going back to the game over screen. So need to fix some things. One way I like to handle this kind of issue is I try to avoid doing too much work in the init function. That's one of the reasons why I made this. I didn't make it, but I should have made it game init function. And another thing is that because all this player stuff should be in a player init function. Because that will allow us to reload. This is one of the things that always like gets you once you get everything working, and then you realize that this part doesn't work, and it's kind of important. So I made a player init. I'm going to hook it into game init. Game init also needs to do a thing called reload here. And what reload does is it actually pulls the PICO-8 cartridge back from the file system. And the point of that is it reloads the map. So we used imset to like write over the map in a bunch of places. And that's not great. So we need to make sure we overwrite that stuff. Another thing is we have these areas here. This needs to be an area init. We can actually put the camera in there too. Because you want to make sure that you end up with really like all your Lua structures need to be clean. So we added a bunch of entities to these areas and stuff. We want to make sure that they get completely reset back to nothing. And I also need to call. Remember this when I did this terrible thing and I said this is bad? This is when I have to, yeah. I need to do area init first and then entity init. And it should be no problem to call game init directly here. I shouldn't have to check anything. Let's see if that works. That does not work because I'm still not reset. Oh wait, actually no, that should have worked. Because I should be setting the player's HP to 1. What could that be? I mean, could it be the player? Well, no, because damage is right here. Why would that not work? Good thing that I didn't do the fun thing. I did this instead. I'm overwriting this. Let's just make sure this is working. So it should just stop the game when I push X now. So it's getting in there. It's just that I'm still getting taken directly to the game over screen for some reason. I thought that when I called this player init, it would just overwrite all this. I mean, it should just overwrite all this information. But it's possible that the order of operations is not right, or you know what, I didn't actually call game init. You're right. That is a good tip, and one that I always forget. I think that the issue is that in my intro, I actually don't have an intro init, but I should call game init inside. I call it inside init, but I really should call it inside inside the intro somewhere, because it needs to know when to do that. Another thing I sometimes do is I just call this function directly, which that might work just fine. Actually, if I do that, I don't have to do any of this other stuff, I think. I'm not sure that feels pretty dirty, but because I could just do that. I'm going to call game init and see if it doesn't like blow up. Okay. All right. That's fine. The reason why I started immediately is because I'm reading all the button presses in one frame. So I need to do, there's one more little thing I need to do for quality of life. And that is I need to do like a lockout on the input. So I'm just going to call it input lock, I guess, or I'm going to call it iTimer. That's what I'm going to call it. I'm going to set it to 0 in the most basic case, and I'm not going to make that there. I'm going to put it into I'm going to put it here. Right. And then when you call your init function, or when you change scenes, you say iTimer equals something like that. Yes, thank you for that link. I always forget about that. So this makes it so that we have to have a timer, which when we switch into the game, we don't want to set the timer. We want to say equals 0 here. When we switch from game over screen, we do want to set timer. Just like maybe 2 seconds or something, maybe 1 second even. I'll say 2 seconds just in case. So when we switch to intro, we need to set it, and when we switch to game over, we need to set it. Just so they can't, like, if they're hitting the button rapidly, they can't click through the screens. Yeah. 2 seconds is kind of long. I'll switch to 1. But now we have, okay. All right, so that's not everything I wanted to get done in 2 hours for sure. And I need to do just a couple more things. I apologize for leaving music to the end, but I'm going to do something here. But I'm also definitely going to use something else I've written before as inspiration. So forgive me. Just checking some notes here. I think I just realized that I won't be able to hear this because of the way my headphones are set up. Let's let me see if I can fix something. Okay, I'll be able to hear it a little bit. Hopefully that's not annoying. I'm going to use a lower speed. This is the music editor. I'm not going to explain everything because I understand everything. But I'm going to make a tiny loop here with some sounds and call it music. So I'm going to use the phaser, I think. I'm going to set the octave down, and I want it to do a fade in. So I'm going to put the volume down because I think it's kind of... Can you hear that at all? It doesn't seem like PICO-8's audio is going to. Anybody? Okay, let me... Nothing. Okay, that's not great. One second, I'm going to do what I can. I may need to take just a 1 minute break here and see if I can get this set up correctly. I know that the stream's almost over, but okay. I'm going to just go ahead and do it live. I'm just going to go ahead and play with my OBS settings and see if I can't get a different... How's that? Is that coming through? It sounds like it's probably really loud based on my OBS settings a second ago. Sweet. Okay, excellent. I'm busy, buddy.
What are you doing?
Go get mama.
Can I see?
My son is making a guest appearance right now. Okay, so this is I'm going to use this as a just primary loop.
What are you trying to do?
I don't know what I'm trying to do.
You're trying to make a game?
Go ask mama. Go ask mama. Sorry about that. He does actually. We do play PICO-8 together.
You want to make a game?
Yes. Go ask mama.
Yeah.
What deny? Yeah, we actually play with PICO-8 quite a bit together. Okay, all right. Yes, I'm gonna use this as like a really basic baseline. I cannot hear it on my end. I think it's because I have it set up to capture, and that makes it unfortunate. But I also have an example to work from, so I'm just gonna see if I can. Sorry to cheat a little bit here, but I can hear it. Never mind. Tell me if it's too quiet. I'm just going to set up some really simple effects here. I can't hear it when it's playing there, but I can hear it when I push the buttons for some reason. Okay, so this is the sound effect editor. I've made two sound effects that look like that, what I just showed you. They're both kind of like bass lines. I'm going to go ahead and here in the pattern editor and set them up so that they play together. So sound effect 0, sound effect 1, push space. I've set the loops up so they loop together. Yeah, just sounds like, you know. I'm going to make it, so I'm not done. I'm going to do one more pattern, and I think, how do I want to do this one? I think I'm going to do something simple. I don't know music, so see if this sounds. We'll see. Probably didn't sound like anything right now because I'm just. Oh, you know what? That's way too fast. This third pattern is kind of like the main thing. I don't know. We're going to loop it at 16. So we're looping that at 8. We're looping this at 4. So it'll only do the first 4. So we'll do 8. This will do 16. We'll come to the pattern. We're going to do the first one. Then we're going to build up one step. Then we're going to build up one step more. And on this one, we're going to loop back. On it, so we're going to loop forward. And what this means is it'll play 0, and then 0, 1, and then 0, 2, and it'll go back to 0, 1. So it'll be like, I can't hear it on my end now. When I go to play it, I can't hear it for some reason. But hopefully that's not too annoying. Okay to go? Too annoying? Bueller? I'm just going to go ahead and use it. Okay, thank you. Okay, I'm just going to go ahead and use it. Yeah, so I'm going to start the music when you switch to the game, I think. So maybe I'll do it. I can't do it at game init because that starts right at the init. I got to basically do it here in the intro when you're switching from the, here, I can just do it right here. So it's really simple to play music in PICO-8. You just say music and then do that, and it will start playing. So we get nothing on the intro screen. And when I push X, you should hear some audio. Yes. Okay. Next. We're done with time. I don't know. This is supposed to be what, 2 hours? I'm not sure because I'm more than happy to keep going because I have more to show, but I also don't want to. I want to make sure people are interested in seeing more before I continue. Does that tilde mean that I should keep it around 2 hours, or is it like 2 hours and more is okay? I think that's the idea, right? Okay. All right. Sounds good. I can't hear it. So for some reason, I can't hear it when I'm playing it in this app. Maybe I can hear it in the other one. I'm going to start a second instance. Maybe I can hear that one. No. That is frustrating. There's one more thing I can try. This is going to be kind of annoying, possibly. Bear with me. Thank you. Yeah, so it's difficult to work on the music bits specifically when I can't hear it out of my own monitor, because I do have another machine here that I can play it on as long as it's not too loud. Okay, let's do this. So we have that one basic song, but there's a little bit more we can do. Oh, yes, I'm going to do sound effect right now. That is the plan. So sound effect. Let's see here. Okay, I can't hear it, so let's lower the volume. I'm flying blind. I want to change it to be like this though, and it's way too slow. I know that it's going to be too slow. What does that sound like? Does that sound like when you hit an enemy? I imagine it sounds something like it. Will there be a VOD? I feel like I don't know the answer to that. I feel like CJ does. Okay, I've got a little bit more volume here now. All right, that's going to be our enemy defeated sound effect, I guess. So that's pattern number 3. There's so many ways to do this. So the unfortunate thing about doing per entity update and like per entity functions is that I want to add a sound effect. I'm going to have to add it to each entity probably. There's ways to do it where you could call like a global function that does it for everything, or I could use a second level of metatables to do like really basic or like, super functions kind of. But I think what I'm going to do instead is I'm just going to say if the enemy detects that it needs to be deleted, it's going to play the sound effect for it being hit, which was 3, right? Yeah. Can't even dust my game. I need to set the HP above 1. Oh, I need to make life. That worked. I could hear that. I forgot. We didn't do HP. Let's do HP. That's pretty vital. It's also very easy. So we're going to come into the player here. They already have HP. I'm going to turn it back up to like 4. And we just need to do a little bit of UI for it. So when we're drawing the player, we're going to do some UI. And the way we're going to do it is we need to do a text to do, I'm going to use this little heart icon to do hearts because it's free. And all we need to do is do a little for loop between however many hearts the player has. And this dot dot is the string concatenate feature in PICO-8 or Lua. So essentially for each point of life they have, I'm going to add a little heart to this life string that I just made. And then we just print it. And we're going to print life at, we have to make sure we print it at the camera X and camera Y. And also I want to do it 8. 8 is red. So I'm actually going to do it offset from the edge of the screen just a little bit. Like that. And hearts go away when you get hit. So there's a sound effect. There's a life. Onward and upward. We don't have anything else to do sound effects for because we're out of mechanisms. So we could either make it juicy, so we could add like some like visual effects and add some polish, or we could add more features. And I think features are more fun. So I'm going to do that, unless somebody has something they want to see in particular. I'm going to do a little bit of work right here, right now. I think. Oh, immediately looks better. Let's do just a little bit more. Oh, well, that doesn't help if I don't use the tile I just made. I'm not setting collision or anything on these, so we get a little, at least it's not a black screen now. Oh, no. Oh, so when I'm reading the entities in from the entity init, I set the tile to 0, but I just added a background tile, so now I'm going to set it to tile 2. So come over to the entity init, and here where I'm updating the map, update it to 2 so we don't leave a hole. Look at that. Okay. Next, I want to make the camera a little bit nicer because it kind of like jerks from one area to the next, and I really want to make it do that like classic like slide thing. So here, it's actually pretty easy, I think. So we're getting the current area, or we're updating the current area automatically, and then we're just setting the camera. So instead of doing that, what we're going to do is we're going to get temporarily whatever area we should be in, regardless of what area we are in right now. And though I don't think we really have to do that. I don't think we have to do that. We're not going to do that. We're going to do it this easier way. We're just going to update the area. But what we're going to do is we're going to get the X and Y for the camera, the X and Y we want to have ideally, regardless of what we have currently. So calculate the X and Y we want the camera to have. And we'll just say if cam.x is not equal to AX, then do I use a vector? No, see, that just gets tricky. I could lerp between them. I don't want to get too tricky because it doesn't have to be that complicated. So I'm just going to use an if in this case. So if it's less than AX, then add 8. If we do 8 pixels at a time, then it'll never get like offset. If we do a lerp or a linear interpolation or something, it could get messy. So not equals. This might work. I'm like, there's no logic. I just realized in how I'm doing some of this, but I'm gonna just, it might work just fine. I think it's just by sheer luck that it's going to work, if it works. I think that works. That looks about 1,000,000 times better, personally. One thing I want to do is in any of these cases, I actually want to add a new method here to tell whether the camera is scrolling currently or not. Because I kind of want to, I don't want enemies to move. I want to kind of lock things down when it's scrolling. So if the camera's moving, then I'm just going to set it to true. I need to do this. And by default, I'll just set it to false every frame, unless we calculate that we need it to be set to true. And then what I'm going to do is in the game update, I'm going to make it so that when the camera is scrolling, I'm not going to update anything else. So that will make it so my things don't animate. Nobody moves. It kind of gives that feeling of like the area is sliding in. Hey, that worked. That was kind of nice. Okay. That's not great because it can bounce you out repeatedly, but I think it's okay. Ooh. I think it's red because the hearts are red. That seemed kind of buggy at the end there. Probably because I used button P. I don't know. Another thing I'd like to do is the game is kind of hard to play right now because you can't tell when you're invulnerable or not. Okay, that works. I'd like to add some kind of feedback so the player can tell when they're invulnerable. There's a lot of ways to do it. You could lerp between multiple like separate colors. Is my camera frozen? There we go. There's a couple different ways to do it. We could lerp between some separate colors, like for a flashing effect, but I think the base, I'll just set a color on the character that we're using. I mean, it's set at 12 currently, and when we are invulnerable, I'll actually change this code. If player.invul is greater than 0, then we'll run the code to subtract it. And we'll also set player.call equals maybe pink. Let's see if that works. Oh no, it won't work because I didn't set it to be used. In the player draw function, we have to come down here and use the color. That's quite a long invulnerability period. It would be better if it flashed, I think, but I think it's acceptable. Right. What's next? Let's do mechanic now that we kind of made it look a little bit more acceptable. Let's do keys and doors. Because keys and doors are fun and difficult with the way I've designed some of these pieces. Let's make a little key. Looks like a key, right? And now let's make a door. What does a door look like? It needs a keyhole, which is kind of like this. And I could leave it just like a block like this, but I think I'm going to round the edges. Yeah, like that. It's kind of like a door. Okay. So we have this flag set for entities, so I need to set that flag on my key. But now we have introduced a lot of problems for ourselves, because if I put the key down and I go to pick it up, well, first of all, it's not in the entity definition, so we can't use it. First of all, that's the first step. So I'm going to add it above the bat just because. 3 is the sprite. Also, I should have done this in the first place, but it's good to, when you use tables like this, I feel like it's a good idea to name them. It is kind of, in PICO-8 terms, it's kind of a waste because you have limited space. But if you don't name them, then sometimes it can be difficult to tell what kind of entity you're interacting with. So you need to give it some kind of code or something, so you know when you're doing comparisons later to tell, I'm using a key to unlock this door, not like a sandwich. We don't need to do animation or any of that other stuff. We do need to do collision, because that's the only way we'll know to pick it up. So it will need collision. I'm going to give it an update function, but it's going to be empty because I don't think the key needs to do anything frame to frame. And the draw function is going to just draw the sprite of the key, which, remember, it passes itself in. I always forget that. So we're going to print that, and we'll have an X and we'll have a Y when it gets created. So, but again, we need to subtract 4 to offset it. Something like that. That might work. If it works, then yeah, okay. Well, there's no collide function, so I can't pick it up. But if we add a collide function, then I can pick it up. Not collider. Collide function takes what parameters? Nothing. It's handy. And sorry to stop writing that in the middle. I need to give the player some way to hold items. So when the player collides with the key, we're going to add the key to the player's items. I do need to pass in the object, I just realized. And we're also going to delete the key from the entities in the area. So add them to the player's items, delete from the area. It should stop calling draw functions and whatnot when you bump into it, because the player has it. We just can't tell. So now we can come back over here and come back down to the player draw function. Here, kind of like when we're doing life, we're already doing like UI stuff, so might as well do items. So we're going to loop through the items. And we're going to, where are we going to put them? For each item, I need to call the, no, I don't need to call the draw function. I need to call the sprite function. So v.s is the sprite. But the x and y are not going to be based on the item's position or anything. It's going to be based on the camera's x plus something like 12. No, 4. And the camera's y plus 12 or so. That is going to put it up the top left of the screen underneath the hearts. But for each one, we're going to have to move it forward a little bit. So we need to do 4 plus this k. K is going to increment for each item we look at. So we'll just do times 8, I think. It might do something weird. Let's see. It's a little bit like more right because I didn't set it off from the, because it's not k minus 1, right? So I could just subtract 8 to get it back to like the very first position. There. And by looping through the items like that, we should be able to That didn't work. Why didn't that work? Why didn't that work? That is interesting. So only one of my entities is showing up. What did I do wrong? Let's take a look at the entity init. It's got to be a problem in the entity init. So I loop through each tile. This is going through entity def, not like current entities or anything. So it shouldn't be overwriting anything. Oh, wait. No? I wonder if... No? That is surprising. What's going on here? Let's turn on debug. And let's come down to the entity draw. And let's add some debug. We're going to just say print the number of entities in the area at, I don't know, something like 424. Oh, for some reason that put it way out in the middle of. Oh, right. It's cam.x plus. Right. So there's one entity in the area, it says. So that is confusing. But the bats worked, right? I did it once, and I think the bats worked. Nope, the bats do not work. I broke something. Yes, it is only adding one entity. That's great. Is it? Is there a typo? It probably, I mean, it could matter. A.entities. Oh, entites. I bet we're going to find that matters. Yeah. The reason why I blew up there is because it's looking for a hit function on the key. Yes, that was exactly it. The problem is that when there's no table for entities, it creates it automatically, right? Or it should have. But because it was checking the wrong variable, it was never getting created. Or, I mean, it was creating it like why? Yeah, I don't actually. I'm not sure what that effect was right there. If that doesn't exist, it should have still created the correct structure, but maybe it was blanking it out every time. That's what it was, because this never exists. It would never be created. So it created a blank table every single time. So it only read one entity max. That's what it was. Thank you. That was very helpful. So the key has no hit function. That's another thing about doing like item entities and enemies and stuff all in the same functionality is you kind of got to add boilerplate, which probably could get around it, but that's a lot. So I really just wanted to make sure that I could hold a bunch of items, which it seems to be working now. Let's turn that debug off. It's kind of intense. I mean, I think actually what's intense is that I have 1,000 keys in this room. Okay, so I'm not going to put the key in the room with the bats, or I guess I could. I'm just going to get rid of the bats, I think, for a second, just because I don't want to fight them over and over again. So there's a door. In order to work with the door, we have to add the door. I mean, the key is, we can pick up the key, so that's good. The door makes me think I want to add one more function to each of these guys. Let's go ahead and make like the door work. So what's the sprite for the door? Number 4. We will still use the same collision functionality, but we can make the collision a little bit bigger on the door because it shouldn't be hard to hit. For now, we'll go ahead and do pretty standard calls for this stuff. It's a little bit weird that the door is an entity, and it's going to cause a problem, which you will see in just a moment here, and that is we have tile-based collision for walls, and for entity collision, we just do like damage and stuff. And so for the door, we need to find a way to stop the player from walking, but the door is not a tile. And there's probably really good ways to do it, but I'm going to show you a horrible way that works just fine, because that is how we do game jams. So I'm not going to really worry about the code for the collision stuff right this second for the door. I'm just going to get it working. As long as it doesn't crash, I'm happy. Okay. It doesn't seem like it's working yet, though, probably because I didn't mark entity. I've set this flag. And the reason why is because if it were working, then I'd be able to walk right through it, probably, because it can't block me. Yeah. So it happens to be out of bounds. So there are multiple ways to handle this. I'm going to do it in kind of, I think it's not the best way, but it's going to work. And I'm going to add a new function onto this entity called init. And what this function is going to do is it's going to undo something we did before. It's going to set the map tile back. So when we read in the entities, we erase the map tile so that we can draw them. We can handle the drawing code with the entity code. But we want the tile because we want tile-based collision. So I'm going to set the tile back, which is just the reverse of what we did in the setup code. And I need to tell it to call that in the entity init. We're going to add it. See, we set the thing here. Then we're just going to do call an init function, and that'll actually let us do any kind of setup we want for enemies or items later that require, additional functionality. It does kind of make our entities balloon in size, but let's see if it works. Can't walk through it. Okay. There's a door. There's a key. We can pick up the keys. The keys go into the inventory. Let's go ahead and put this one back in here so we can test it. We need to make the key work now. So that's pretty easy because we built all the tools. We have collision already. What we're going to do is when we collide with the door, we're going to look at all the player items. And if the name of the, we're going to loop through each of them, right? And if one of them equals key, then we're going to do a couple different things. First, we need to fix the map again so that we can pass through, right? and not e.s. I really shouldn't hard code this too. This is like the empty tile space, but you know. So we're going to fix the map first, and then we're actually going to delete the door entity, which means you couldn't close it again later with this code, but you know, extra credit or something. So we're going to delete this from the entity code so that it isn't being drawn or anything. That should do it, I think. Oh, no, one more. We have to delete the key from the player's items. There's an argument to be made here that you should do that from within the keys code, but I'm not going to worry about it. I need to close this for loop. Pick up the key. Key goes in the inventory. Open the door. It's not bad. So there's keys and doors. Let's feel a little bit claustrophobic. Let's make this a little bit bigger. Let's get rid of this door. Or actually, I want that door. But let's put a bat or a couple bats in here. And let's get rid of this key. If you don't use the correct sprite, so I'm doing it based on the sprite number, right? I use the second frame. If you don't use the correct sprite, it won't read it in properly. Okay. So we can kill the enemies, and we can use keys to unlock doors, but I feel like you need that critical functionality of you kill all the enemies and you get the key. That makes all the difference. Then it feels like a game, right? Plus, we can't do a win scenario until you have something to win against or some kind of obstacle. So let's make that work. The way I'm going to handle that is I'm going to add a new function to areas. So I just added a new area. Let's go ahead and add that in here, actually. And I'm going to add a new function to the second area. And I'm going to call it onClear. Nope, I'm not. I'm going to call it update. That's more generic. And this function is going to check and see whether there are any entities alive in the room still. So the way we're going to do that is we're going to say if this function hash a.entities, so entities in the area that we're currently updating, if it's greater than, or if it's equal to 0, this is not going to work in rooms where you have keys on the ground and stuff, but we'll work around our limitations. So if there's no entities, it's also not going to work because the door is an entity. Hold on. I'm going to have to check entity type, I think, which is fine. This is the kind of thing where you might want to tag enemies. I'm actually going to go ahead and just say, I'm not going to say what kind of enemy it is. I'm just going to use the generic name enemy here. We can't count it, then we have to do it a different way. We have to loop over it. So, and we just check to see if the name is enemy. And if it is, then we return, well, then we aren't going to do anything. Yeah, we're just going to return. So we loop every single frame when we in the update function. If there is something in the entities list that has a name of enemy, it's going to do nothing. If it makes it through the whole loop and there's no entities with the name of enemy, then it's going to do something. And that something is, it's going to drop a key. And the way it's going to drop a key is, as always, there is a right way and a wrong way to do this. The right way probably is to create a specialized function that can create entities for you. The I need this to work and I don't want to build a whole bunch of scaffolding way is we kind of just do the same thing we're doing here. We just need this code. So we make a new entity. We just have to know where to look for the key, and we have to know where we're going to put it. So first we have to decide the location. I'm just going to put it in the room, you know, on like near the top left corner or something. So the way I'm going to do that is I'm going to get the x of the room and multiply it by 8. And I'm just going to add a little offset of like 3 to it. And I'm going to get the y of the room, and again, add just a little offset to it. So that puts it kind of within the room that we're currently looking at. And we don't have this v, and this is where I'm going to commit a cardinal sin, because as your game goes on, you do as you do. And I'm going to say, I could write like a lookup function to find the key, or write a function to give me a key specifically, but I know the key is number 1 in this entity list. And this is going to go horribly wrong if I reorder this at some point in time. But if I don't, then I can actually just say, look at the first item in the entity definitions. You might, if you're going to do something like this to yourself, you should make a note, because this is definitely something that I would regret if I did this. But it also probably is going to just work. This update function is going to run every single time. So the last thing we want to do is, after we only wanted to do this once. So we have a couple different ways to do it, but what I'm going to do is, after we've run this and generated the key, I'm just going to replace the update function with one that does nothing. So I'm going to say, if I made it nil, it would cause an error. So I'm just going to say like that. This function is going to override itself and then end. And then it's not going to do anything after that. And the last thing we have to do in that case is, we have this area update function, but it doesn't call code per area. So it's kind of like the last thing we need to do is say, if we're not scrolling, then update the current area. I'm not passing DT in there, and I should be. Make sure it's an in-game update. Oh, right. So the other areas we made so far don't have update functions. And there's a couple different ways to handle it, and this is one way. Could just check. Oh, this is the shorthand if statement, by the way. If you put brackets or parentheses around this conditional, you don't need the if, you don't need the then, and you don't need the end. It just does whatever to the end of the line. So this is just saying, you know, if there is something called update, then go ahead and do it. And actually, since I'm doing it that way, I don't need to override it with a function. I can just set it to nil. I want it to be, look at that. So you kill the enemies, you get the key. Is this going to work? Oh, it did. Yeah, that's kind of like a game. I mean, you could do something very game-esque with that amount of logic, I guess. Let's do something else cool. Let's give areas their individual palettes so we can separate them. You could like come onto the map here and make a bunch of tiles and draw interesting rooms. And actually that is a great idea, I think. But another thing you can do is you can use the pal function in PICO-8 to do some interesting stuff. So I'm going to come in here into the area definition. And somewhere, as the code gets longer, I become unable to find things. This is where oh, here it is. I'm looking right at it. I'm going to come in here to the area definition, and I'm going to add a little thing called P, which I probably could name it better, but I don't want to call it palette because there is a palette command. So I'm going to call it P. And when I designed these blocks, actually I used 3 colors specifically. Are you adding procedural generation? I'm not. I mean, you could, but getting something that would be playable, like fun for your game jam, like I think the hard part about that would just be, what do you do when you want to do like the key in the door thing, and how much work do you put into generating areas where those functions work? Because it's one thing to just generate random rooms, but if you want to make sure that you can actually, there are enough keys and there are enough doors and they're in the right places where you can unlock them and navigate the entire dungeon, that's a non-trivial problem to solve. I feel like that would eat up your whole game jam, solving that problem. But I mean, if you have a super like clever idea of how to do it, I think there's some easy procedural generation you could do. You could decide which areas have enemies, for example, and then spawn different amounts of enemies based on something. Or you could, since I just added the update function, you could make a room that spawns enemies over time. So those are all things you could do. It depends on how far you want to go with the procedural generation. I'm going to start out just by doing something like changing the highlight color to I'm just going to start out by changing like the highlight color to red, I think, or pink, because I'll do this main color to red. So 6 goes to 14. So the best way to do this. You could add per area draw functions, and that gives you like complete control. But if you just kind of add too much complexity. What I was thinking I could do is I could just pick, like for example, my tiles use 3 colors here. So if I just assume I know I'm always going to use 3 colors, I can say the first color is the base color, the second color is the highlight, and the third color is the shadow. So I can just redefine the colors and say, I'll do the base color is red, 8, highlight is 14. So I'll do 8, 14, and I'll leave I'll do 2. So 8, 14, 2. It's going to look really like red and garish probably. So I'll set that P, and I'll come down here to area draw. And I'll say if area.p. So I would only do it, if I have one set. And I'm going to use the pal function. And what the pal function does is it kind of like rewrites colors. So like I said, this base color of 6 or 5 is going to become 8. So we rewrite 5 to whatever the first thing I typed in the palette thing. And then this highlight color is going to be, or 6 is going to become 14. So 6 to the second color. And I think the shadow is 1, right? Yes, color 1 is going to go to the third color. Another thing you probably want to do is reset the palette every time you draw, just to make sure that for rooms that don't have, the palette changes don't persist between areas. Oh, I just realized this is not going to work at all because I'm drawing the entire map at one time. I'm going to have to do a per area drawing thing. I don't think I can do that this time. I'm going to backtrack. So sometimes in game jams, you make decisions. And sometimes you don't have the tooling built in. I did not build this in such a way that I can easily add that when I thought I could. Or no, that's not true. Sorry. I am drawing the whole map, but only one room is visible at a time, so it might work. Oh, P. Oh, right. I have to do this. Yeah. Sunday morning realization order. Yeah, I mean, that's pretty hard on the eyes, but the idea is now I have one room that, you know, well, there's bats there, so it's all red. You could do something interesting too, where you after you, so just all I did right there, all I did was I added in the place that where we create the key, I took this P and I set it to nil, so it won't exist anymore. So we will stop overriding the palette. So you get this interesting effect where after you kill the enemies, the room reverts. You know, you could do like a dark room that lights up or something. It's kind of difficult to do gradient colors in PICO-8, but you know, if you work within your limitations. What else? We could do screen shake. I didn't do that in my prototypes at all, but you do screen shake when you get hit. In order to do that, we need to add some functionality to the camera. Yes, shake X and shake Y, or shaky. And this might work. We should handle, okay, so all I did was I added some variables to say like add some offset to the camera, but I haven't set them anywhere yet. So we'll come in here to when this is where the player takes damage. And we'll just say cam.shakex equals a random number. We'll try to keep it not too bad. So this is, if I do random 4 minus 2, it's going to be between -2 and +2. So we do the same thing for X and Y. This is not X. This is not actually how I want to do this. I just realized. The shake has to be random on every frame or else it doesn't look shaky. I don't need to keep that. What I need to do is I just need to set shake to be a random number of how long I want the shake to be. So 1 second's quite long. If I just set it to something like even a quarter of a second might be long, but what I'm going to do is I'm going to set this variable to how much time I want it to shake. And then I'm going to, in the drawing code, I have this area update. This is where I need to subtract. So I have to say if cam.shake is greater than 0, then I don't even need that, but cam.shake equals, take the max. Basically, we're just subtracting delta time from it until we get to 0. And then we use SX and SY for the shake. It's going to generate some random numbers, and if the shake is ongoing, and then it's going to just add those numbers here. And maybe that'll do it. Let's see. Oh, that worked. Collision detection leaves a little bit to be desired, but suddenly feels way better with screen shake. There's a talk, I'm sure everybody knows this, there's a talk about the art, I think it's called The Art of Screen Shake, and if you haven't seen it, you should find it and watch it. It's on YouTube. Adding these kinds of things into your game makes a big difference, and it is definitely the kind of thing you want to leave till a little bit later, but it can change how you feel about your own game while you're building it. I actually just want to get hit by them now because the screen shake feels nice. It might be too much, but I like it, so. That text is red because the last thing we colored was the hearts, so the red text is kind of left over, but that's a lot of what I wanted to show. I mean, there's a couple different things you could do from here with the things we've built. You know, let me see. That is the one. Yes. Highly recommend it. It's a good time. I mean, it's just entertaining, first of all, but also educational. Isn't that the best? Yeah, so what I was saying is with the mechanisms you've built here, you know, there's a lot of different things. Everything is like a key in a door in this kind of game, right? So a button that you push down that opens the door, like you could make an entity that doesn't move. And I mean, you could probably build it in like 10 seconds here. You just take like your ground tile and you put it down and you make a button. Like what color is a button? Orange maybe or something? I know I didn't do a boss, but so that kind of looks like a button. But we need also the button when it's pressed in. I think I don't want this. I think I need just like this. That looks like a button. It kind of looks right. Yeah, that's acceptable. I'm gonna ship it. That's sprite number 7. We go and add an entity. We can't, keep in mind, we can't put it in front of key because if we do, that room will start spawning buttons. So the sprite was 7. I really should do something about the fact that I have to redefine these functions over time, but let's actually just draw it, I guess. So these are all the same things we've done. I'm actually not going to offset it by -4 because this is kind of like a tile, like the door. And though it does affect the collision if I don't. So probably I should do that, even though it looks kind of weird. Nah, I'll just set the collision bigger. It doesn't matter. It doesn't matter. Speaking of, I do need to set the collision size. Something like, I don't know, 4. Update, draw, collide. So I mean, we could just set collide right here to update the sprite. When you collide with it, just set it to 8. That's the That's the pressed in version. It's not going to do anything amazing, but update, draw, collide, hit. Is that all of them? I do have a knit, but I don't think I need it. Yeah, that's all of them. So I don't think it's going to do anything yet, but I'm pretty sure we can press it in if we walk on it. No, we can't. Why can't we? Oh, because I didn't set it to entity. I'm sure somebody was screaming at me about that. I didn't create an init function, so I do need to do that too. Oh, what am I doing? Oh, okay. that's funny. That's a really good bug actually. This is the kind of thing that you build your whole game and you like this. I'm like, oh, I'll just add a button. I have all the mechanisms. All I did was add a sprite with a simple function. It draws the button on top of the player. So what now? There's a lot of options you have in this kind of case. The simplest one is just to say, there's actually no reason why we can't just draw the player last. It doesn't really affect it with the enemies because you bounce off anyway. I don't think you'd notice that you've drawn over them. So obviously the button doesn't do anything, but yeah. Game dev. This is game dev. The button is shown on top of the player. I love it. So yeah, the button doesn't do anything, but you can press it in. You could make it do something just here, just like we did with the area. You know, here we're checking the update function on every frame. And if you want to say, if my sprite is 8, you know, even if you don't want to do, you could do like a pressed or unpressed variable here. You could do pressed equals false. And you could say pressed equals true only when they're colliding, right? And otherwise, you could actually say, I'm pretty sure this is another order of operations problem that's going to get me. Okay, so in the game update, we update the player first, and then we update the entity, which means the player's update function is called, and then each entity's update function is called. So if I update the button on collide, but then the button calls its own update function, it's going to overwrite whatever I said in collide because it's last. So I can't just overwrite it here. So that's pretty funny. I don't know if there's a really good way to deal with it. I was just thinking I could make it so it's only true when it's actually like pushed down. I mean, there's ways you could do it. Like you could set a timer, for example, to track like how long the button stays pushed down. And so you're not actually testing whether it's pressed or not. You're just setting a timer. And so if they collide with it, you just set it to 1. And if e.ptimer is greater than 0, then e.s equals 8. What was it? Yeah, 8. Else e.s equals 7. And then it's just a matter of e.ptimer equals We keep a minimum of 0, and we use the same delta time. Just subtract from it. We use max because if this is bigger, we want this one. If it's smaller than 0, we want 0. And we're just setting the sprite based on whether they've stepped on the button recently or not. It will stay pressed for 1 second after they step off of it. And if you, this is, you could just do it like this, and now it almost looks like we did it right. You can do all kinds of things like stepping on the button, and then you loop through the entities in the area, and if there's any doors, the doors open. Or they open for, you set the P timer, and when the P timer runs out, you loop through the area for all the doors and close them if that runs out. Because we have, the doors are marked. We'd have to do something a little bit different to make this door closable, because it's not really closable. I didn't do a boss. I think I'm going to wind down here pretty soon because we've talked about a lot of different mechanisms, and I feel like this is a pretty extensible example of how to do things. If we were going to add a boss, I think all I want to do is use the bat, but it's not enough how it is now, right? It's kind of too simple. So let's take this bat and let's copy it here. And let's just make some tweaks to it to make it look more like a boss bat. It will look like a boss, trust me. We have all this functionality that we need for the boss too. There are better ways to do it. I'm going to copy and paste this right now. You could break out all these functions into a separate thing and reference them, and it would make it nicer. But I'm going to set the sprite to 18. I'm going to give it, 10 HP. And I'm going to make it a little bit faster. It's 2 frames in the animation. I could make the animation just like a hair faster, I guess. I don't know if that will make it more menacing or not, though. We're going to double the collision radius. Might even need to make it bigger, but the reason why is because also, I just realized we want to play the sound effect on hit, not on, or actually I set it to be on death, but if we do it on hit, it'll work for the little ones too. Let's just fix it right now. Okay. We're not going to touch the animation. We're not going to touch any of the logic. We could, but we'll just leave the bat how it is. We could make the player take more damage. That's kind of mean. And I'm going to use a new function, actually. It's called SSPR, and it's the... Actually, I'm not sure I need SSPR. Yes, I do. Yes, I do. SSPR is the complicated sprite drawing function. So you can't just give it a sprite number here, this e.s. You have to give it the position on the tile sheet. And the position on the tile sheet here is, it's x16, y8, kind of like that. You could calculate it. The way you could do that is, the furthest most point on the x is 127, and then it loops back around. So the tile sheets, never mind, sorry, I'm confusing myself. What I'm trying to say is if you look at this tile sheet, there's 16 tiles wide, right? So I know the sprite number is 18. So if I modulo this with 16, that gives me my y, or my x, because it's going to be 8 times 2, which is 16. So modulo it with 16 to get the x, divide it by 16, enter to divide by 16 to get the y. If that doesn't make sense, then I understand. but you modulate with 16 to get the x value. You have to multiply by 8 because it's in pixels. And you integer divide by 16 to get the y value. I need to look at a reference because I always forget how this function is called. Okay, so you give the x and the y, and then the width of the rectangle on the sprite sheet, which is 8. It's 8 pixels wide, 8 pixels tall. And then I think it's the width of it's in the position on the screen, and then the width of the position on the screen. So the position on the screen is e.x minus 8, e.y minus 8. I'm making it bigger is what we're doing here. And then I'm going to make it, instead of drawing it 8 by 8, I'm going to draw it 16 by 16. And I think that should be enough. Who knows if it will look right, but let's see if that works. Oh, look, it's a big bat. Not hurt. That wasn't too hard. One problem that we have is, just like before, when the player could get hurt multiple times in one frame, the boss is having the same problem. It can take damage multiple times, so we need to give the boss invulnerability briefly. Not too long, though, but if we give it maybe not even a second, maybe half a second. If we get half a second of invulnerability on a hit, we can say e.invul equals. I don't know why I set it up there. I have to set it down here. And then if e.invul, we only want to do this damage stuff if how's this going to work? Oh, actually, no. This is how I want to do it. And then in the update function, we just do the same trick again, where we subtract the delta time. One thing we might want to do is change its color when it's invulnerable. It's orange, so we'll just maybe set it to red. It wouldn't be visible in that one room. Maybe yellow? 10? I just looked at it and I forgot. 9 to 10. Always reset your palette. Well, not always, but you know. Oh, I guess that's how it goes. That is, well, that's challenging. It's just so erratic. And it has so much help. Okay. There we go. I think that is a good place to stop. I mean, I have to do one more thing. I have to do one more thing, though, because we've come this far. We have to do one more thing, and that is we have to give a win state. Because it would feel wrong if you could lose, but you can't win. Don't worry, it's going to be a great fanfare. It's just going to say you win. So we're just going to do that, and it takes you back to the intro, calls intro update. You can see how a system like this, with it split up into scenes, it starts to look not too different from something like Unity in that sense, because if you think about the project organization from the beginning, while you're building the first bits and pieces, you can build yourself into a place where, you have this extensible framework. You don't just have like a game, but also you have the pieces to build something even beyond what you expected, which I think is the, part of the fun. When a second ago when I was like, oh, let's add a button, and it's easy because of the decisions you made in the past. When the boss is done, we just say scene equals win, right? I mean, if I can defeat the boss again. Should have taken his health down. I need a longer sword. Forgive me, I'm going to reduce the boss's HP. Oh, that didn't work. Hold on. One more thing. This is getting a little bit spaghetti now. I have to set the timer thing so that it doesn't immediately go back to the intro screen. There's an ending. You go back to the beginning. You can play it again. You could put the boss, in here such that it's actually, yeah, I win. Put the boss in here. I should have made the bosses room more interesting, but that's a full game. There's enemies, there's a boss. So I think that's where we're going to stop this time. If anyone is interested, I'd be happy to make this code available. I can put it on GitHub. I'm not sure that I'll have the I'm not sure if I'll be able to go through it and like comment it out or clean it up. If I say that I'm going to do that, then I'm just never going to end up putting it online. So I will be happy to just put it on GitHub as is. Buyer beware. Yes, thank you, CJ, for helping me out in the comments and helping me do all the checking and whatnot. And as we were trying to make last-minute changes to make it all work today. Great, I'm glad it was informative. I wasn't sure how helpful it was going to be. I'm just going to go through a bunch of stuff really fast. But yeah, I'm happy to give like practical examples for things. Thank you. This was fun. It would be interesting to do a little bit more streaming maybe. Okay. I don't have any video to roll or anything, CJ, so. Thank you, everyone. I'm going to end the stream now. Oh, by the way, if you have any questions about this or anything really, if you just want to talk about PICO-8, I'm on Twitter. You can search my name. I think my @ is Toraton. It's the same as, oh yeah, you can search that, or you can search my name, Josiah Pertlebaugh. I'm probably linked. Yeah, you can find me from those links too. I'm going to be at the jam site in Code Chrysalis. I'm going to be doing mentoring, as CJ is saying in the chat. So I will probably just be walking around and trying to help you solve whatever technical issues or otherwise that you've run into. But yeah, feel free message me anytime about PICO-8, about anything programming in general, and I'm interested in all of it. I'd love to chat. So, okay. Thank you so much. Bye.